This is part 3.2 of optimization problems. This will be released right after the last one if you've just seen. I didn't realize the last one to be so short. I don't think I picked enough questions to be in the other part. Doesn't really matter. I'll go over them now. Okay, so anyways, first question, we've got this. We've got this shape here. The surface area is this, and what do we want? Given that the measurements of the prism are such that its volume is maximized, find in exact simplified form the volume of the prism. Okay, so the area is cube root 27 pi. This is just the same thing as saying 3 cube root pi. But anyways, okay, so if we say that we've got a radius r, and then we've got this height h. Well, this top area is going to be 2rh. We've got half pi r squared here, and then half pi r squared on the other side. So that's pi r squared plus 2 pi rh, and then plus, this is going to be a half 2 pi rh. Okay, because you can imagine as a cylinder, it's going to be 2 pi rh, but if you have half of it, it's going to be a half 2 pi rh. You'll get this. Just simplify it and then collect like terms. Why have I not collected? Oh no, because there's a pi there. Okay. That equals this. What am I going to do? I'm going to take away pi r squared from both sides, and then I'm going to factor out a h, and then I'll just divide from both sides to get it all in terms of h. We've got the volume, so the volume is equal to, it's pi r squared h, but it's half of that, because obviously it's not a full cylinder. So half pi r squared h, and then we need to put that h into there to get this. This looks a little bit confusing, but we can take out an r from the denominator, like this. We can also take out the 2 plus pi. You'll get this, and just keep this in mind here. So when we're going to differentiate this, because we want to maximize the volume, so we know that it's going to be something to do with differentiation. When you differentiate something like this, you've got f of x multiplied by g of x. So that's the same thing as saying, so it's differentiating this multiplied by this, and then adding differentiating this multiplied by this. But if you have a look at this is a constant, okay? Because, I mean, yeah, so if you imagine like this, we've got this. This constant multiplied by g of x, okay? The constant will differentiate to 0. So it's 0 multiplied by g of x, which is just, it's just, that. Oh, sorry, I should have actually distributed the r here to imagine it as a constant here. Yeah, so this is the constant, sorry. Okay, so we've got that constant multiplied by g of x. Constant differentiates to 0, so this entire thing just cancels out. And you've got this multiplied by just differentiating this. Okay, hopefully that's a bit easier for us to differentiate. So in terms of r, dv over dr, this becomes just 3 cube root pi, and then this is minus 3 pi r squared. You'll get that equals 0. It equals 0 because it needs to be a stationary point for us to either maximize or minimize it. Okay, and then just expand it here on the top, and then I'm going to multiply by 4 plus 2 pi. Add this to both sides to get that. What can we do? Let's just go on to another page. So you can imagine this is just pi to the 1 over 3, and then this is just r squared. And what else here? So we're going to divide by pi. If you imagine just like your power, like laws of indices, when you're dividing two things together, you're basically taking away their powers. So this is a third pi, take away 3 over 3 pi. So this becomes 3 pi to the minus 2/3, like that. And then so if we just square root both sides, we'll get r equals that. Okay. This is the same thing as obviously just taking the reciprocal and then getting rid of this negative sign. And what is it here? So this is 1 to the half, and then this is pi to the 2/3 to the half. Obviously a half multiplied by 2/3 is just 1/3, so this entire square root just goes away. You get that. This is the volume that we got last time. Wherever we see an r, we're just going to plug this into there to get that. This looks a bit complicated. Just take your time slowly with it. Maybe use a calculator if you prefer. Just take it slowly. This actually cancels down really nicely. This two cancel. You'll get that. So the volume is just pi over 2 plus pi. We have a straight line L with this equation. I'm going to rearrange this for to a more usable form. So this becomes 2y equals minus 3x plus 8. Divide by 2 on both sides to get this. We've got d here, so we want to find the distance squared. Okay, it's just the distance formula. So this is what is it? This is point x and y. So this is going to be 5 minus y squared plus 8 minus x squared, and that gives us d squared. We know what y equals, so we'll just plug that into there, and then just take this really slowly. Just make sure you don't make any mistakes. Use a calculator if you want. I mean, you've gotten like the hard part bit done. Collect like terms, you'll get this, and then just, you know, swap these around so it looks like this. We're saying let f of x now equal to that, okay, and use differentiation to find the stationary value of f of x. Okay, so just differentiate this, you'll get that. So this is minus 13 and then plus 13 over 2x. You get that, that equals 0 because it's a stationary value. Add 13 to both sides, multiply by 2, and then divide by 13. Or you might just see here, x has to be a 2 for these 2's to cancel out to get 13 equals 13. So x equals 2. To show that this actually minimizes the value, we're going to differentiate twice. This constant goes away, and this becomes just 13 over 2. This is greater than 0, so it definitely minimizes. This value of x definitely minimizes the distance. Okay, that's the original line L, and then here we've got state the coordinates of R and find as an exact set the shortest distance of the point Q from L. Okay, so Q from L, so if you imagine first of all, okay, this line LR, QR is perpendicular, okay, it says it somewhere here, where is it? QR is perpendicular to L. Okay, so that means that the gradient QR is a negative reciprocal of this one, so y equals 2/3 x plus c. It passes through the points 8, 5, so just plug that in. This is GCSE maths. C equals minus a third. Plug that back into there to get that. To find the coordinates of R, these are simultaneous equations. It's just where the two curves, where the two lines intersect. You'll get that multiplied by 3, multiplied by 2. Add 9x, add 2, 13x equals 26, so x equals 2 here. Just plug it back into any one to get what y equals. Y equals 1. So the point R is has coordinates 2, 1. Okay, what else do we want? We want to find the shortest distance. Okay, so we know that when x equals 2, as we found out last time, when x equals 2, when x is equal to 2, it minimizes d squared. So we'll just plug in x equals 2 into there, get what that equals. D squared equals 52, so d equals 2 root 13 units. An open box is to be made from a thin sheet of metal. That means you can just not imagine that it has any like thickness to it, because obviously these calculations that we're about to perform are not going to be exact. It's a cuboid, base length of x and a height h. Okay. Determine the value of x in terms of h when the surface area of the box is minimum. So the surface area, we've got xh here, and then we've got that 4 times. So we've got this side here, that side in the back, this side here, and this side here, and then we have x squared and x squared. So it's 4xh plus x squared, and the volume is just x squared h. We've got that v. In other words, yeah, v, the volume, it has a fixed volume. Okay, so that means we can just imagine it as a constant when we're going to be differentiating. We're going to rearrange this for x squared, and then we're just going to plug this. Sorry, we're going to rearrange this for h, not x squared. Then we're going to plug that into there. You'll get this. Just to expand this, x and x squared cancels down a little bit. You'll have that. This is 4v x to the minus 1. And then if you differentiate, this is minus 4v x to the minus 2 plus 2x. That equals 0, because if it's either a minimum or a maximum, there must be a stationary point. You can just put that into like that form. It makes no difference. Add 4 over v x squared to both sides to get this. Oh no, I've not done that for some reason. Oh yeah, of course, yeah, because, well, we know what v equals is x squared h, so we'll just plug it into there. X squared and x squared cancel, so minus 4h plus 2x. Add 4h on both sides, and then divide by 2 to get x equals 2h. Okay, and then we're going to show that this is actually a minimum value for x. So we're going to differentiate this twice, for a second time I mean. So minus 4 multiplied by minus 2 is positive 8vx to the minus 3 plus 2. Plug x into there. Oh no, sorry, you don't even have to do that. You can kind of just say that, well, we know that x is definitely going to be positive because it's a length. So all of this is definitely going to be positive. Okay? But if you'd prefer to just show it normally, well, we know that a half x equals h. Okay? So the volume is x squared h here. So if we plug that into there, we get the volume is equal to 1 half x cubed, and then multiply by 2 on both sides to get 2v equals x cubed. So x equals the cube root of 2v. Now you can plug that into there. The cube root and the cube cancel, so you'll have 8v over 2v, which is just 4, and then 4 plus 2 is 6, which is positive, so this is definitely a minimum. A solid right circular cylinder of a fixed volume, so remember we can imagine it as a constant, has a radius r, height h. It's always good to draw diagrams. Whenever you're doing these types of questions, you always want to draw diagrams and just already have a plan before you start it out. So just, make an equation for the height, or sorry, not the height, for the area or for the volume or something like that. Just whatever the question wants you to do, so you can always referencing it. You can always reference it when you're answering the question. Show clearly that when the surface area of the cylinder is minimum, h to r is 2 to 1. Okay, so the surface area is going to be 2 pi r h to get just the outside area. Then we've got pi r squared, so 2 pi r squared plus 2 pi r h. The volume is constant, and the volume is pi r squared h. Okay, we're going to rearrange for h. This is very similar to the last one. We're going to plug that into there. Pi r squared cancels down a little bit. This is the same thing as saying 2v r to the minus 1. You can just differentiate it like this if you prefer. This becomes minus 2v over r squared plus 4 pi r. To get that equals 0. What is it? We know what v equals. It's pi r squared h. Just plug it into there. We know what we'll get. What? Oh yeah. Also here, I just need to mention one thing. So if we're plugging this into here, don't just plug in h into there, because you won't, you'll just cancel down things and it'll just be a waste of time. You'll just get back to where you ended up. So just leave this as it is right now. R squared cancels down a little bit. Add 2 pi h to both sides. Cancel out pi's, and you'll get 4r equals 2h. You might just see here that this is obviously in the ratio 2 to 4 or 1 to 2. If you prefer, you might want to show it as a fraction. So r over h equals 2 over 1. Therefore, the ratio is just 2 to 1. Oh no, sorry, we need to show that this is actually a minimum. Okay, differentiate this for the second time. So this is a positive 4v over r cubed plus 4 pi. We know what r equals. R equals a half h. Am I going to even use that? Okay, never mind. I'm going to plug this into there, and then we'll get this for the volume. And if we plug that into there, the r cubed will cancel just like it did on the last question. R cubed cancel. This is just 6 pi add 4 pi. Oh no, sorry, 8 pi. I don't know why I said 6 pi. 8 pi add 4 pi, 12 pi. That's obviously positive, so this is a minimum. We've got this weird shape here. We've got this length here, which is 1.5, and this height, which is 3. You can just ignore all of this waffle. You only need this to actually draw the diagram. Show that the maximum volume of the cylinder to be cut out is pi meters cubed. Okay, so you can imagine this. So imagine we bring this height here. Okay, and imagine we just look at this triangle here. Okay, I'll draw it here. This is the cylinder. Okay, and it touches this cone here. We've got height h, and then we have this bottom length here, which is 1.5. And then we'll just call this, which is the radius of the cylinder, we'll just call it r. And then we can call this height here h. Okay, this makes that r as well, and then this also becomes h. So this here must be 3 minus h. and then this is 1.5 minus r. I don't think I actually wrote that on for some reason. Oh no, it doesn't even matter actually, because we can just consider this triangle and then use similar triangles with this bigger triangle. So if this is r, this is 3 minus h, and then we look at this bigger triangle, so 3, 1.5. Okay, and then we'll do this 3 minus h divided by 3 equals r divided by 1.5. Okay, I just did it, I just swapped it around, it doesn't really make a difference. Multiply by 3 over 2 on both sides, and then multiply by 3. You'll get this, multiply by 2. Have I done that? Okay, for some reason I distributed this, doesn't matter. Multiply by 2 on both sides, you'll get that. Add 3h. Oh no, sorry, yeah, just rearrange for h, you'll get this. The volume is going to be pi r squared h of this cylinder. I'm sure you already know that. We know that what h is now, so we'll just plug that into there. We'll get this. We can't collect like terms anymore. We need this to either be a maximum or a minimum. What does it? Oh yeah, so it says maximum. Okay, so we're going to differentiate this. So we'll have 6r pi minus 6r squared pi. That equals 0 because there's a stationary point there. What is it? Oh yeah, so the pi's cancel, some r's cancel. R is not going to be 0. You can just factorize it like this and say, you know, you've got two solutions to this specific equation here. R equals 0, R equals 1, but it can't equal 0 because it's a length. So R must just equal 1. We've got what the height is, so 3 minus 2 is just 1. So R is 1, H is 1. And then we've got pi r squared H for the volume of this cylinder. We know that H and R are both 1, so this is just pi. And that's done. Show that this is actually a maximum, differentiate twice. Show that this is actually a negative. This is going to be negative 6. Oh no, sorry, we need to plug in r equals 1 into here. You'll get that. That's negative 6 pi. And that's a maximum. The point P lies in the curve with this equation, so that its distance from the point 10, 2 is least. Okay, so it's a minimum. The point 10, 2 doesn't lie on this graph here, because if you just plug in x equals 10, you're not going to get y equals 2. So we'll just say it's somewhere there, okay? And then the point P is going to have x coordinate x, and then a y coordinate x squared. You know, just take a second to think about that. This is the x coordinate, this is the y coordinate. We know that y equals x squared, so this is x, and then x squared. Okay. Then we want to just find the distance. You know, just use the distance formula. I'm sure you know how it works. You'll get this. Just expand this out. It's going to look hideous, but it's fine. You can just collect like terms. And now, let d squared equals equal f of x, and we'll come back to this later. But if we just say that this is f of x, then we can differentiate it to find what the minimum value is. So it must have a stationary point. Divide by 2. Oh no, I've not even done that. So if you just look at this here, we've got some cubic, okay? We don't know what the solution is going to be, so we're just going to try stuff. If you try 1, well, we've got 4 minus 6, which is minus 2. Minus 2 minus 20 is not equal to 0. If we try 2, we've got 2 cubed, which is 8. 8 times 4 is 32. 32 minus 12 is 20, and then 20 minus 20 is 0. So x equals 2 is a solution here. Okay, and we're going to factorize this. So if you imagine this, well, any cubic is just this linear term here multiplied by a quadratic. Okay, and the quadratic will be in this form. And then we can compare coefficients now to just find out what a, b, and c equals. A here definitely equals 4, because the only way to get an x cubed is for a to equal 4 here. And c must equal 10, because minus 2 multiplied by something equals minus 20, so that's definitely positive 10. You do the same thing with to get b. So you just think to yourself, well, what's the only way I can get something x's? So we have we've got 10x here, and then minus 2bx equals minus 6x. So b equals 8. You can kind of just run through that and write that down. You'll get b equals 8 anyways. This here, you can just, well, what I did here it doesn't really matter if you factorize this out or not. This here could give us a few solutions. We don't know which one it'll be. We already know that one of them is x equals 2. So we just need to find out if this has any solutions. You can try factorizing it or put it into a quadratic formula. But the easiest way to do this is just to first of all calculate the discriminant, because we don't even know if it has any real solutions anyway, so we'll just plug it in. We've got b squared subtract 4ac, so 16 subtract 4 multiplied by 2 multiplied by 5. This comes out as a negative, so it means this has no real solutions. So the only solution is x equals 2. And to show that this minimizes, we're going to need to differentiate again to get 12x squared minus 6. Plug in x equals 2 into there. This is definitely a positive, so this is a minimum. Okay, and then plug in x equals 2 into here. Actually, no, it's actually easier to plug it into here because this is already all collected. So we've got 2 squared, which is 4. 4 minus 2 is 2. 2 squared is 4. Add 2 minus 8. Sorry, 2 minus 10, which is minus 8. Minus 8 all squared is 64. And then you've got 64 add 4, which is 68. For some reason, I factorized out of 4. Literally makes no difference. It just makes it easier to simplify the said. Anyway, square root both sides, so this becomes a 2 root 17. And that's all the questions done for this part. The next part will come very soon. Anyways, thank you for watching.